Alright, hello everybody. It's Mr. Culp again. What we're going to do now is we're going to learn some very simple Scratch programming on our Vex base bot. At this point in time, you should have your Vex base bot completely built, ready to go. So the first thing you're going to have to do is you're going to have to get Vex code up and running on whatever system you're on, whether it's Windows, Mac, or on a Chromebook. And let me click this off. Okay, so if you are on a Chromebook, the best thing to do is to install the Chrome extension. I'll include a link down below in the video description. All you have to do is go to that link and install the extension. If you're on a Windows machine or a Mac or anything else, or even on a Chromebook, you can go to the web-based application. And it's codeiq.vex.com. I will link that down below. Okay. And finally, if you're on a Windows machine, you can also download the native application and install it if you want. There's a few minor advantages to using that native application over using the web-based interface, but I'm not going to go into that in this particular video. You can install it if you want. Alright, when you first come here, okay, if you are on a Windows machine, and this only happens on a Windows machine, it's going to tell you that the web-based Vex IQ Vex Code IQ requires a Windows driver to be installed. You only have to do this once. If this is the first time you're using this particular computer, whether it's a laptop or a desktop or whatever, and once again it's only on Windows, you're going to go ahead and you're going to hit that download button. However, once you've done it once, you don't have to do it again on that machine, although it will warn you every single time you start up the web-based Vex IQ. So you only have to do it once. I've already done it, so I don't need to do it. Okay, now no matter what machine you're on, you're going to go ahead and you're going to plug in your USB cable into your machine and also into your brain. So I've got it plugged in, and I'm going to go ahead and turn it on. And you turn it on by hitting the check mark up here. And there we go, we're good to go. Now then, a couple of things. Oftentimes, if you hit the check mark and it doesn't turn on, there's a couple of things to look for. Number one is make sure your battery's charged. I'm going to pull this battery out just to show you. But number one is to make sure the battery's charged. And also, if a battery hasn't been used in a while, and I see this after we go on vacation or something, you know, we go on a winter break or fall break and we're gone for a week or 2 weeks, or of course summer vacation if your robots haven't been used. The batteries go into a hibernation mode, okay, or sleep mode. You got to wake them up. And you can both wake the battery up and check your battery power at the same time by doing this. I'm going to remove my battery. You don't have to remove your battery to do this. It'll just be easier to see, provided my camera stays in focus because it's having some major focused issues. So I'm going to remove my battery. And on the end of the Vex battery, there is this little button right here. This little button. I'm going to hit that button. And my battery's getting low. It shows me I got two lights right there, so that means I'm at about 50% or lower. There's 4 lights. If 1 light comes on, you're at 25% or lower. 2 lights, 50%. 3 lights, 75% or lower. And then of course, if you have 4 lights come on, you're at 100% down to somewhere above 75. You're above 75%. But the act of pressing that button also wakes the battery up. Okay, and so let me put this back in there, and there we go. Another thing is I notice that sometimes students don't seat the battery completely, and so if they're hitting that button and it's not turning on, you know, check your charge, wake the battery up, and also make sure it's seated pretty well. All right, so let me get back to where we were. All right, well, we got this turned on and we're plugged in. What I'm going to do now is I'm going to go to File, and I'm going to do a new blocks project. So we're going to learn block programming or Scratch type programming on the Vex code. We're not going to do anything super complicated. We're going to learn how to move our robot around, basically. All right, your project was never saved. Save now. I'm going to discard because I don't have anything on have saved. So this right here is the default. And I'm going to zoom in just a little bit so you can see that better. Okay, let's go over a few areas of the coding application, Vex code. Over here, this right here contains all of the tabs, okay, all the tabs that have your code blocks. And by clicking on those different code blocks, it brings, or the different tabs, it's going to bring up the different code blocks. So looks is all about printing and drawing on the Vex brain, the Vex IQ brain screen. Okay, and then sound, you can actually play sounds and even music if you want. Okay, and then events is all about responding to different events like timers and passing messages back and forth. Controls, where all your control statements are, for example, your loops basically. Okay, your repeat until loops, repeat a number of time loops, your if then statements and if else statements. Sensing is where all of your sensor information is going to be. Okay, there's some built-in sensors on the Vex. We're not going to get into those today, but the gyro and inertial sensing. Okay, operators is all about comparing, doing math and stuff like that. Variables is all about controlling the variables that you make and you set, reading them and setting them. And you can actually make your own blocks called functions. Once again, we're not getting into anything like that. And then making comments. We're going to talk a little bit about comments. But for today, we're basically just going to focus on these three right here. Okay, or actually three. Looks, sound, and you'll notice there's nothing here about driving the robot around. And that's because we're going to have to add those, and I'll show you how. It's really simple. So we're going to focus on the drivetrain, driving the robot around, a little bit about looks, drawing on the screen, printing some text, and then a little bit about sound. All right, when we start a new project, the first thing that we have to do, and students forget this all the time, they'll be like, hey, Mr. Culp, there's no commands to drive the robot around, or there's no commands to move my motors. And that's because they probably forgot to add devices. So step number one, the first thing you're going to do when you start a new program or a new project is you're going to add devices. And you're going to click this button right here. And this button, it's kind of got a weird shape, but what this is it's the shape of the motor and sensor ports that are on the Vex. So this is shape right here. Okay, and so you're going to click there, and the devices are the motors and sensors that you have plugged in to your robot in these different ports. You'll notice that automatically it shows that we have an IQ robot brain, second generation. Okay, and so what we're going to do is we're going to add a device. Now, another big mistake students make is they go, oh, well, obviously these are motors, right? Because they're used to move the robot around. So I'm going to add two motors. And so what they do is they click here, but that's not what you want. Vex actually makes this really, really easy. And if we have a two-motor drivetrain, we're using two motors to drive our robot around, we can instead do this right here, the drivetrain two motor. Okay, we usually only add single motors when we want, maybe we've got a gripper or a claw controlled by that single motor, or maybe an arm or something like that. Okay, so for us, for driving the robot around, we're going to make sure we select the two-motor drivetrain. So let's go ahead and do that. So I'm going to select drivetrain two motor. And now it's asking us left motor and right motor. And this is another mistake, little gotcha that students do, is they get their left and right confused. Not because they don't know their left from the right, but they forget to define what forward is on the robot. Oh, I think my robot's dying. They forget to define, what is forward on their robot. So for me, I'm going to make forward this direction right here, go in this direction right here, okay? And so my robot's going to drive, when I tell it to go forward, it's going to drive this direction. And what that means is my motors are up front. It means I've got a front wheel drive robot. So what that means is this robot right here, or excuse me, this motor right here is my left motor. And I'm going to trace that right here to port number 1. So my left motor is going to be port number 1. And then over here, this motor over here, which is plugged into port number 6, it's going to be my right motor. And then I'm going to choose brain inertial. All that is that when you start driving, it's going to reset and read the gyroscope and the accelerometer. So it gives you, and it's going to use those in driving to give you a little bit more accurate driving. We don't have to change any drivetrain settings with the base spot. Okay, we would only need to change these if we put bigger or smaller wheels on here, or we had a gear ratio. So I'm going to click done. All right, so now we're set. And you'll notice as soon as we did that, okay, as soon as we did that, right over here, we had this drivetrain tab appear. And that's where all of our drivetrain commands. Okay, let's go ahead and get started. So I'm going to click right here. Okay, so let's write a short little program that's going to cause our robot to drive forward for 3 seconds. So, because I'm using commands to drive my robot forward, I'm probably going to look under the drivetrain tab. And let's see here. Yep, right there, drive forward. Now the drive forward, oh, and by the way, you can see there's a little drop down right here, okay? If I drop down, what I can do is I can cause it to go forward or reverse with the same command. And so whenever you see commands or functions that have those drop down boxes, that gives you options that you can change. Not every single, as you can see, not every single command, not every single function has those, but many of them do. Now the thing about the forward command, it doesn't say for how long or even how far. All this does is it gets our motors driving forward, and they're going to stay driving forward, okay, with no input from us. We don't have to do anything else other than start them going forward until we tell them to do something else or the program ends. Well, we want to do this for 3 seconds. Now what I'm going to do is I'm going to come over here to the control tab, okay, right here, the orange one, the control tab. And I'm going to choose the very first one up here, which is wait, okay, wait. And you'll notice it says wait for 1 second, but I wanted to wait for 3 seconds. I wanted to drive forward for 3 seconds. Well, notice I can change what's inside of here. So I'm going to change that to 3 seconds. And then finally, I'm going to come back over here to drivetrain, and I'm going to look to see if there's anything that turns my motors off. Drive forward, turn, turn, turn. Ah, right there. Stop driving. So what will happen is that when we click start, I'll show you how to do that in just a second. When we click start, okay, it's going to do each one of these commands. I'm going to label them 1, 2, and 3. It's going to do each one of these in order. So the first thing it's going to do when started is it's going to start us going forward. Okay? And then it's immediately going to come down to here and it's going to wait for 3 seconds. And what that means is it's going to stay right here on this block right here. Okay, on this function right here. The wait function. It's going to stay there for 3 seconds and not leave this block until those 3 seconds are done. And then it's going to drop down to here after 3 seconds, okay? After 3 seconds. And it's going to click, it's going to stop driving, turn off our motors, and then it's going to end. I don't have to do anything right here, okay? I don't have to do anything right here. Once it gets to the end of the program, it's going to shut off our robot. It's going to stop, okay? All right, so let's go ahead and give it a try. So what I'm going to do, I need to reconnect. My robot's dying. Oh, got to turn my robot on. There we go. All right, connect. Another big mistake that students make is that they forget to download. Okay, once you've got your program written, you actually have to download it to the robot. And that's going to be this button right up here in the upper right, the download button. What that does is it transfers our program right here, okay? And it's going to send it to the robot through the USB cable. So I'm going to click download. Oh, one more thing I'm going to do. I'm so sorry. I'm going to change the name. Notice that our name up here is Vex Code Project. I can change that name to anything, and it should be a descriptive name. So I'm just going to click on it, and let's call this Simple Driving. Okay, Simple Driving. I'm going to click Save. All right, now that doesn't save it to our computer. What it does is it just changes the name there. Okay, so that when I download it, we'll be able to see that name on the actual Vex controller, the Vex brain. You'll see that in just a second. So let me go ahead and hit download. And compiling, there we go. It's now transferred to the robot. Now I can run it in two different ways. Way number one, and it's to me the least common way, is hitting the start button. Most of the time your robot, you want it to be, moving around and doing stuff and going places. And being tethered to a cable like this, it just, isn't what you want. But I'm going to go ahead and run it from here. I'm going to hit the start button. When I do that, you'll notice here it says calibrating inertial, and it goes for 3 seconds and then stops. Let's run it again. Let's count. Let's just make sure. 1,000, 2,000, 3,000, and stops. So there we go. Right about 3 seconds. Now there's another way to start it. I'm going to unplug the USB cable. Without being tethered to the computer. Maybe you put it on your Vex board and you're ready to go, you want to run it. So what I'm going to do, I'm going to hit the X button. I'm going to show you how to get to it from the home screen. So I'm going to hit the X button a whole bunch of times. Okay. So I'm at the home screen. I don't know if you can see that. It says home right there. And I'm going to use the left and the right buttons to move the highlighted instruction, the highlighted icon. Right now I'm on the drive icon. I'm going to go one to the right, boom, programs. That's what I want, because we wrote a program. It's going to be in our programs area. And then I'm going to click the check mark to select it. And now notice something, okay? Notice that right down here, okay, it says simple driving. And that's what we named our program. And in fact, that's our program. It's in slot number 1. There's 8 slots, 1, 2, 3, 4, 5, 6, 7, and 8. If you look up here on the screen, you can select those slots up there. So you can put up to 8 programs on there. But I'm in slot 1. It's called Simple Drive. And now that I've got it selected, all I have to do, I'm going to press the check mark. We get a couple of other options. We have the run option, the run for 2 minutes, run for 1 minute, and the information screen and the delete screen. Okay, but I'm going to click run. Run for 2 minutes and run for 1 minute are most often used in competition, when you want to make sure that your program only runs for a set amount of time. Our program doesn't go anywhere close to 1 minute or 2 minutes in length. It's like 4 seconds in length. All right, so I'm going to come back over here and I'm going to highlight run, and I'm going to hit the check mark. And there we go. It does exactly the same thing. And then to get back, I just press the X button, and then I'm already on that screen. I can press the check mark again. Oh, come on. You can't really be holding it when it's doing the calibrating inertial. There we go. And that ran for about 3 seconds. So we're good to go. All right, now we're going to move on. We're going to do a little bit of driving based upon a time isn't always the best way to drive. Oftentimes, it's much better if we know the exact distance that we'd like to drive. And if we look over here in our drivetrain, our set of drivetrain functions or commands that we have, and if we look down through here, we can see that we've got some functions, some blocks, okay, some blocks that allow us to drive for a particular distance. So what we can do, let's get rid of all of this right here. Let's experiment with those. And by the way, that is the best way to learn how to program. Just experiment. So right here on this drive forward for 200 millimeters, you'll notice that we've got, once again, we have one of those drop-down boxes, and we have something that we can enter text into. And the drop-down box will allow us to switch from forward and reverse. And this right here allows us to type in how far we want to go. So we might want to go 500 millimeters. And by the way, this drop-down box right here allows us to switch between millimeters and inches. I'm going to use millimeters. And unlike the drive forward command, okay, where once we said drive forward, our motors turned on and stayed moving forward no matter what until we turned them off or commanded them to do something different. The drive forward for 500 millimeters or drive forward for a distance command or block does something a little bit different. It's actually going to execute this and then stay there until it's driven 500 millimeters. All right. So we can go ahead and once again download. And when I look up here, I've had to disconnect my Vex. I can see I'm not connected because it's not green. So let's go ahead and connect. And once again, that communications port. I'm connected, so now I can download. Once again, I'm going to put it in slot number 1. It's going to be called Simple Driving. And there we go. So now when I click Start, it's going to do the calibrating inertial, and then the wheels will move, and it will move at approximately 200 millimeters in this case. If I wanted to go further, like maybe 800 millimeters, I can change that. And once again, once I change it, I have to download it. That's a common mistake. Now let's hit Start again. And there we go. Much longer now. If you look down through these drivetrain commands or blocks, I keep calling them commands, blocks, same thing. There's a lot of them. These right here allow you to turn. So this right here, let's make that a little bit shorter, would go. Now there is one thing I want to show you on here. You'll notice there is an option right here. And when I click here and don't wait, what that means is, okay, here's the thing. What will happen is when I run this program, it's going to drive forward for 400 millimeters and wait until this command is done, until this block is completely finished. In other words, until we've driven our 400 millimeters. And only then, after we've driven 400 millimeters, will it then go down to this block and then turn right. Most of the time, almost 99% of the time, that's what you want. But occasionally you want it to start driving forward for a certain distance and not wait. Go ahead and do some stuff. Maybe you're going to play some sounds and some music and do other things. And in that case, if that's the thing that you want to do, you say and don't wait. So it's going to start it driving forward, okay? And it's going to go ahead and immediately start doing these other blocks, okay? While it's driving forward. And then once it drives forward 400 millimeters, wherever it is in the program, it will stop driving forward. Like I said, most of the time that's not the behavior that you want. And for beginners and for students, it's a big place or a big thing that introduces bugs and things. It's hard to figure out what's going on. So for right now, you might want to say, and wait. Basically, it's going to do this block right here, and it's not going to do anything more until this block is completely done, until it's driven 400 millimeters, and then it will go to the next block. All right. A couple of the things I want to call your attention to real quick. On drivetrain, if you look down here, we have blocks to set the velocity, what speed we're driving at. The default is 50%, so if you don't change it, it's automatically 50%. You can make it go faster by putting these. You can put one at the very top if you want to drive the same velocity the whole time. But we can say set drive velocity to 100%. Let's do this. Let's just kind of take a look. So we're going to set drive velocity to 100%, drive forward for 400 millimeters, and then let's do this. Let's set drive velocity, let's say 25%, and then drive forward for 400 millimeters again. I'm going to hit download, and let's hit start. So what should happen is it will drive forward quickly, and then it should slow down. Yeah. So the wheels move very quickly, and then they slowed down. So essentially what happened, once again, we just went block by block. We set drive velocity to 100% and moved forward for 400 millimeters at 100% velocity. Then it came down to this block. We set drive velocity to 25%, so 1/4 power, and then drove forward for 400 millimeters. Once you set drive velocity, you don't have to set it again. All your commands will be at that particular velocity until you change it again. All right, let's have a little bit of fun. I want to show you real quick the looks and the sound. Okay, looks allows you to do things like draw on the screen, print text, etc. So let's do that. And one thing we should always do, and once again, students often forget about this, is we should first clear the screen on the brain if we're going to print to it. So let's clear all rows on brain, and once again what that does is it's going to clear the brain screen, all except for that top line, okay, not the top line, that status line that's on there. And then let's set the cursor to row 1, column 1, and once again we can change these, so we could go to row number 2, okay, row number 2, row number 3, row number 4, etc., and change the column where it starts printing. And the drop down is on the brain or on the console. If sometimes you'll see console there, and that prints it on the computer screen. So I'm going to set the I'm going to clear the screen. I'm going to set the row so it's up in the top left, and let's print hello Vex. Hello VexBot. There we go. And we can also draw. We can let's draw a circle. And this is the x and y coordinates, and this is the radius of the circle. So let's do an x of 100 and a y of 100, and a radius of 10. And we can set colors. So let's do this. Let's set the pen color to purple. I like purple. And maybe the fill color. Normally when you do this, it's going to be a non-filled in circle. Okay, but let's fill it with purple. Let's see. There it is. Set fill color to purple. And then let's play some sounds. Okay, let's play the siren sound. So we're going to start with the siren sound, and then maybe we drive forward for 400 millimeters. And then maybe we turn right for 180 degrees. Whoa. And then maybe we drive backwards for 400 millimeters. And then let's play another sound. Let's play the ta-da sound. There we go. So when started, what we're going to do, let's just go down through it. We're going to clear all the rows on the brain. In other words, we're going to clear its screen. And then we're going to set the cursor to start printing at row 1, column 1, right up here in the upper left. We're going to print hello VexBot. We're going to set our pen color. We're going to set our pen color and to purple. Then we're going to set our fill color to purple. Then we're going to draw a circle. That circle is going to be somewhere right around it here at 100, 100. The X is 100. The Y is 100. We're going to play a sound. We're going to play siren sound. Then we're going to drive forward for 400 millimeters. Then we're going to turn right for 180 degrees. Then we're going to drive for 400 millimeters in reverse. And then we're going to play the ta-da sound. So once again, let me download that and hit start. There we go. Hello, VexBot. There's our circle. We drove forward. Now we're in the turning. Oh, I gotta let it turn. There we go. And ta-da. So what happened there? What happened there was, remember that inertial? We're going off the inertial drive mechanism, the gyro and the accelerometer. On the turn right for 180 degrees, it actually wants you to, it wants to turn right because it's sensing, okay, with that gyroscope and that accelerometer. So it will know when you've turned 180 degrees, and I was holding it so it was never turning. So I had to actually put it down here on the tiny little area that I have and let it turn. I'll show you again. All right, let's go forward. All right, now it's in the turn, so I got to let it turn. And once it gets to 180 degrees, it then goes backwards again. Anyways, okay. Here's what I encourage you to do. Start experimenting. The best way to learn how to code is just get in there and start experimenting. Set yourself up an obstacle course or something along those lines, and start experimenting, start writing code, and it's the single best way to learn. All right, if you got any questions, just put them down